Have you ever thought of the tremendous power required to drive ships? Power to drive them through gales and storms to Australia or China, Russia or South America? Power that drives not only big liners like the Queen Elizabeth, but also smaller vessels like this one coming into the port of London. In a turbine-driven ship, the power comes from steam just as in a railway engine, but there are no pistons or cylinders, none of the to and fro movement of connecting rods and cranks as on the locomotive. All you can see in the engine room of a turbine-driven ship are several long, squat casings. These are the turbines or rotary steam engines, frequently used in cases where very great power or very great speed is required. The idea of a rotary steam engine is a very old one. Hero of Alexandria designed one nearly 2,000 years ago. The principle is very simple and is something like that used nowadays to work the garden lawn sprinkler, although in this case water is used in place of steam. Nothing much, however, came of Hero's idea until it was revived in the 17th century by an Italian named Branca. His method was to arrange a jet of steam so that it revolved a vaned wheel, very much like a modern water wheel. The Pelton wheel, for example, is a similar arrangement driven by a powerful jet of water, a simple method of turning the movement and energy of the water into a rotary motion. By improving on these simple ideas, Charles Parsons in 1884 built the first really efficient turbine, and he succeeded because his design was cleverly arranged to extract the last ounce of energy from the steam. At first, Parsons tried making a simple turbine rather like the one of Branca, but he very soon realized that the steam was not being efficiently used, that it still retained much of its energy after leaving the blades of the wheel. He hit on the idea of using this surplus energy to drive a second wheel and perhaps a third and fourth. The problem was to redirect the steam and concentrate it through a jet onto the other wheels. This is how Parsons solved the problem. The blades are made with a cross-section, like this. The steam jets are arranged on the side of the wheel so that the steam enters from one side, impinges on the blades and drives the wheel around. Owing to the shape of the blades, the jets of steam are turned through 90 degrees and escape from the other side of the wheel with considerable speed and energy. This escaping steam and thrusting its way clear of the blades also helps to send the wheel around. Rather like the water in the lawn sprinkler. The next stage is to redirect the steam so that it will be able to drive the second wheel. This is done by a set of fixed blades attached to the casing of the turbine, which are similar in cross-section to the blades on the wheel, and deflect the steam again through 90 degrees so that it impinges on the blades of the second wheel at the same angle as on the first wheel. In the actual turbine, this arrangement is repeated through many rows of moving and fixed blades to ensure that the best possible use of the energy of the steam is made. You can see how the Parsons turbine combines the ideas of Hero and Branca. Here we have the moving blades, here the fixed blades. In this way, the energy of the steam is used to the best possible advantage. Notice that the rings of blades increase in size. and that the space between the rotor and the casing increases. This is to allow for the expansion of the steam as it moves from high pressure to low. High pressure here, low pressure here. Here you see a rotor in the last stages of construction. The expansion of steam happens at great speed, and the rotor has to be very accurately and strongly constructed to stand up to the high speeds of revolution obtained. Note the increasing sizes of the blades. The large blades in the foreground are for reversing. When the rotor is finished, it is lowered into the casing which contains the fixed blades. The top half of the casing is lowered onto the turbine. And so, from this simple principle is developed the tremendous power and speed of the engines of modern steamships. Turbines are used to drive generators in large power stations. And are installed in many ships of the Navy to give them their great speed.